today is going to be all about 3D printing in the workshop. It's going to be aimed at people that don't have 3D printers. Perhaps you've seen some of my videos where I've 3D printed stuff and are thinking, is that something that I should do? Is it a machine that I should have in my workshop? What I will do in this video is take you through the steps you need to go from an idea in your head to a plastic part, to give you an idea of the total workflow from concept through to physical object. And I think that will help people understand if 3D printing is something that's for them. It's not for everyone. I'm not going to try and persuade any of you one way or the other as to if it's a thing that you should be doing, but hopefully I'll provide enough information for you to make up your own minds as to if it's an area you want to visit. It's possible to create really complex parts in 3D printing, but for the purposes of this video, the common thread going through it will be this part. It's a little thumb screw that I use to hold the access panels on for my table saw. By keeping the object simple, I hope that we can focus on the process rather than the object that we're creating. And by doing that, you'll get a clearer view of exactly what's needed to become someone that can use a 3D printer in your workshop. My 3D printing workflow can be split into 3 parts. You've got the modelling of the parts that you want to 3D print. You've then got the processing of that model into a form that can be used by the 3D printer, and then the actual printing of that model with the 3D printer. I'm going to go into each of these in a lot more detail, and you can use the chapters facility on YouTube to skip backwards and forwards. So let's get started with the modelling and move over to the computer. You can, of course, just take a 3D file that's already been created by someone else, such as the files available on Thingiverse, and print those directly. Now, what I have found is that whilst this seems like a good idea, quite often you want to modify the designs that are available, and so you can't get away with not knowing how to use a CAD program. So now we'll look at CAD programs. The program I'm going to look at, I've only been using myself for a few hours, and that is Tinkercad. It's an online tool, so it's something you can explore without having a 3D printer, and you can have a play with. It does have tutorials, which seems to work reasonably well. And this is basically, you can think of it as a drawing program, but it's a drawing program in 3D. Now, this isn't meant as a CAD tutorial or a Tinkercad tutorial. There are plenty of those available on YouTube, but I'll quickly go through making the thumb bolt, and you can see how it works. Tinkercad works by basically merging objects together. So I'm going to start by finding an object that's a little bit like the object that I'm after. I'm going to look for something like a gear or a cog, something like this. I'm literally just going to drag it onto the page. Now with my mouse I can move it around, I can change the view and so on. And I can use these little guides to set the size that I want it. So I want it to be 11mm high. And I want it to be 17mm wide. And I want it to be 17mm in this direction as well. This gives me my basic shape, but our thumb bolt has got a hole going all the way through it because the 6mm thread needs to go through. So I need to select another shape. I'm going to select a cylinder this time, and this cylinder is actually going to be a hole. So I'm going to select the hole option. Let's just move this over so you can see it. And now I'm going to change the height. Because this is a hole, the height is a little bit arbitrary. As long as it's taller than the object it's going in, it doesn't really matter. And I'm going to make the width of the hole 6.5, so that it'll accept a 6mm thread. OK. Now I have a hole. And I can put that hole inside this piece here. Now I want to line the two up, so I can click this here to look at the top, and then I can drag and select both those pieces and select the align tool here, and then align centrally that way and align centrally that way, and those two things are now
correctly aligned. I now select them again, I can click the merge tool and it will merge the hole into the object. You can now see that I've got a hole in that object. I also need to create a hexagonal hole for the top of the nut. I can use this polygon tool, and in the same way I can create a polygon that's the right size. So if I select this one here, so I know this needs to be 10 and I know that this one needs to be 11.2. Now I don't want this on the floor, I need it above the floor, so I can use this little cone thing here and just drag it up, and I'm going to drag it up 3mm so that I've got 3mm above the floor. I'm going to make this a hole again and I'm going to put it into the middle of these objects, just doing it roughly. Now I'm going to select all the objects, the align tool again, and I'm going to align that way in the middle and that way in the middle, and that's the aligning done. And I can now click the merge tool, and there we go. We now have our object created, and it looks pretty much like the object that I printed out, although that object I actually designed in SketchUp, which is the program that I've been using for the last 7 years. It's not actually the best program for 3D printing, and I'm probably going to move over to Tinkercad. The last thing that we need to do is to export this object. So we click the export button. Now 3D printers need STL files, so we're going to select STL, and you can see that it's downloaded it.
So that's the object designed in Tinkercad. That didn't take very long because it's a simple object, but obviously some objects are a lot more complex and they can take hours, days or even weeks to design. Let's now look at the next stage of the process, which is taking that design and preparing it for the 3D printer. We're going to do that using a program called a slicer. In this case, I'm using another free package called Cura.
So Tinkercad has saved my file in my downloads folder under a file name called Funbolt. If I double click on that, it'll open up the slicer program, which is Cura. This is a free software made by Ultimaker. I'll leave a link to it in the description. And you can see what we have here is a representation of my 3D printing surface. This shows the total volume that my 3D printer can print. And just like the other programs, I can move it around, I can drag it about, zoom in, and so on. The slicing program's main purpose is to convert the 3D model into instructions that the 3D printer will understand. These instructions are called G-code, and all they are little commands to the 3D printer that tell the printer how to move its motors and how much of the filament to extrude in order to print the piece. There are a lot of parameters that you can mess around with, such as the quality. I normally print at either standard or low quality. The finer the quality you use, the thinner the layers are, and therefore the more layers you need, and therefore the slower the print becomes. So I tend to print on either standard or low quality. If I select standard quality for this one, which is 0.2 of a millimetre, normally you don't want to print things completely solid because it's a waste of material. This particular one, there's not a lot of material on it anyway, so I am going to print it completely solid, so I'll keep that to 100%. There are then parameters such as what temperature do I want the print nozzle to be at. This will be written on the filament that you use, so I set mine to 200 for PLA, and then the bed itself can be heated, and that helps adhesion between the part and the bed, because the bed moves backwards and forwards. You need the part to be stuck to the bed. I tend to print with the PLA filament that I use at about 50 degrees centigrade. Support material is where you might have overhanging parts that need to be supported, so I'm going to ignore that. Build plate adhesion is if you're finding your part doesn't stick to the bed, then you can do things to try and improve it. A skirt will draw a piece of filament around the bed just to make sure the filament's running nicely before it starts printing. There are then other options such as a brim, which does exactly what it says. It creates a brim around the piece which will easily easily be removed afterwards, or you can print the whole thing on a raft of material. For this particular one we'll use a brim, and that's about it. You then click slice and it'll create that G-code. Now before we save it to file, we'll preview it and it'll show you what it's going to look like, and I can use this slider to just see how the print is actually going to work. And this preview will show me the printer moving and how it's actually laying down those layers. If I just move up the first layer and then hit play again for the next layer, you can see exactly what the G-code is going to tell the printer to do. So you can use this just to check that things work exactly as you expect. I tend to just go up the print layer by layer, making sure that everything seems to be in order and there aren't any gaps and it's not doing anything silly. And then all you do is save the file. See that it's created a name for it. This is the name of my printer. It's a CR10S, it's a Creality printer. It's given it the same name as the STL file had, and then it's got G-code at the end to tell me that it's actually G-code. So I can now save that. I'll save that to the desktop, click save, and it optionally opens this thing so that I can open the folder and have a look at it. If you want to look at what the G-code actually looks like, then if we open it with a text editor, you can see it's just a text file. These M numbers are just codes. It's like commands to tell it what to do. And then there's just a list of X and Y and how much it needs to extrude that just goes on and on and on. And obviously the larger the parts, the more of these commands you'll have. We now need to get this file onto the 3D printer. Now what most people would do is save this file to an SD card and then take that SD card to the 3D printer and plug it into the 3D printer. Then on the 3D printer you would select that file and hit print and it would start printing. I do things slightly differently.
So we're finally at the 3D printer. There's a few things that woodworkers need to consider if they're having a 3D printer in their workshop. The first is you're going to need to put your 3D printer into a cabinet. Woodwork and all workshops get dusty. 3D printers and dust don't really go very well. So by keeping it in a cabinet of its own, it's going to keep the dust out, and that's going to make a massive difference to your prints. The second thing that a cabinet will help with is keeping the heat in. Now, most of you probably don't have heating in your workshops. I don't have it in mine. And when you've got heating elements trying to keep the nozzle at 200 degrees and the bed at 50 or 60 degrees, then you want to try and keep all that heat inside, not escaping to the cold environments in the winter. Those two things make, I think, a cabinet essential. I made this cabinet. It's a bit Heath Robinson, as you can see. All the green bits on it are all 3D printed. Let's have a look inside. So this 3D printer is a Creality CR10S. I think they still make it. It's about 7 years old. It has been highly modified. So I'll take you through some of those modifications and some of the reasons for why I've modified it. So the first big modification is I got rid of the separate control box and redid all the electronics underneath. This was just to reduce the footprint of the printer. Many printers now come with the electronics underneath, and I would say it's something worth looking for because it just makes the amount of bench space you need for the 3D printer a lot less. The second thing I've done is I've put the spool, which is up here above the printer. Again, that would normally sit to the side of the printer, and that again means you need a lot more space. By putting it above, keep the footprint of the whole thing quite small, and it takes up less space in your workshop. My 3D printer sits on these squash balls. This just helps reduce the vibrations which cause an artifact in your prints called ringing, where you get like these echoes of previous moves on the surface of your print. I've also added these support struts. These are just to try and improve the rigidity of the printer. My favourite modification is this Raspberry Pi. This is a Wi-Fi antenna. The Raspberry Pi connects to the printer using a USB slot, and that allows me to communicate with the printer via the Raspberry Pi rather than having to plug an SD card
into the 3D printer itself. This allows me to run something called Octoprint, which is a web interface which allows me to transfer my file from my computer to the printer over the internet. I'll show you how I do that in a second. So if we turn the 3D printer on now, you can hear the fans going in the power supply. This here's the power supply. You can see the lights coming on. Eventually the Raspberry Pi will boot up and you'll see a blue light come on here. This tells me that the Raspberry Pi is ready to work. All I've done is turn the printer on. It's not going to print anything yet, but if we go back to the computer, we can then look at how I get the files from the computer onto the printer. So Octoprint presents itself as a web page on your local network. You log into it and you have the ability to control the 3D printer, but more importantly you can drop the file that we created earlier, the funbolt.g code, which was the code that tells the 3D printer what to do. We can drop that onto the Octoprint interface and it will upload. Now that it's uploaded, it's here. It's also automatically uploaded here, ready to print. If I now click print, it will start the printing process. And to show that printing process has started, if I look at the temperature, this is showing the temperature of the nozzle and of the print bed. And you can see this is the target temperature of the print bed, and it's just shot up to 50 degrees. And you'll see that the temperature, which is the blue line, is now starting to increase. Once that's at 50 degrees, the nozzle temperature will turn on and it'll heat the nozzle up. Once that's happened, the print will start. So now let's go over to the printer and see what's happening there. So we're now over by the printer and you can see that the bed is heating. See the target temperature is 50 degrees and it's currently 38 degrees. Now the print bed is at 50 degrees, the nozzle is starting to heat up. Any second now we'll see the temperature hit 200 degrees on the nozzle and the printer will self-home itself, ready to start printing. First it extrudes a line down the edge just to get the filament moving. Now it's moving into the centre to start the print. If we look now at Octoprint, we can see that the bed temperature is up to the 50 degrees it needs to be, and we can see that the temperature of the nozzle is at the temperature we set it, which was 200 degrees. We can also see here the ETA for when the print is going to be finished, and that we're 26% of the way through the total time, and we're still on the first layer, layer 0. There are 54 layers in total. And here's our completed print. Just need to get it off the bed, like so. This is the bed adhesion material, which was the brim that we put on, which you just pull off and tidy up later. And there is our little thumb screw. So that was my video on 3D printing for woodworkers. I hope you got something out of it, and I hope you have a better idea for how you go from concept through to final finished printed part. Perhaps I've inspired some of you to investigate 3D printing further. Perhaps I've put some of you off. Let me know in the comments. If you've got any questions, then also leave them in the comments and I'll answer them as soon as I can. If you've enjoyed this video, please leave a thumbs up. And if you haven't already, please subscribe and I'll see you in the next video. Thanks for watching.